Question 2.4. The sum of the first three terms of a geometric sequence is 31 and 1 over 2. The sum of the fourth, the fifth, the sixth of the same sequence is 3 and 15 over 16. Determine the value of the common ratio. So this question, in this question, they are looking for a common ratio. And what we are given a sum. The sum of the first three terms and the sum of the next three terms, because the fourth, the fifth, and the sixth are the next three terms from the first three terms. So the sum of the first three terms is given by this mixed fraction. If you want, you can change this mixed fraction to an improper fraction. What is an improper fraction? An improper fraction is a fraction whereby a numerator is greater than a denominator. So you can change this to improper fraction if you want. So it is mentioned that this is a geometric sequence. So we know that if we have a geometric sequence and they are looking for sum, we can use the following formula. We can use the following formulas. 1 when r is less than 1, 1 when r is greater than 1. But since we do not know the value of r, you can use any. But most of the time, we prefer using the first one. But in this case, I won't be using any of these formulas. I'll be solving this from the general sequence. What is my general sequence? This is my general sequence. So we know how do we generate this sequence. We generate this sequence by using this nth term for a geometric sequence. We generate this sequence by using the nth term for a geometric sequence, right? So term 1, if we substitute 1 here, we get this. If we substitute 2 here, we get the second term. If we substitute 3, we get the third term, fourth term, and so on. So we have the first 6 terms. This is the first 3 terms. These are the next 3 terms after the first 3, right? So the question says the sum of the first 3 terms of a geometric sequence is 31 and 1 over 2. This means when I add a plus ar plus ar squared, I get this. Is that clear? Okay. Term 1, term 2, term 3 is equals to 31 and 1 over 2, right? What is our term 1? Our term 1 is a, our term 2 is ar, our term 3 is ar squared. So this is our first equation. So from this information, the sum of the fourth, the fifth, the sixth of the same sequence is 3 and 15 over 16. So this means when we add T4, T5, T6, we get 3 and 15 over 16, right? This is what we have. T4, T5, T6, 3 and 15 over 16. Then we substitute our terms here. This is what we get. Then from here, what we will do, we'll take out the common factor, right? Of what we are looking for. We are looking for ratio, right? So we'll take out the common factor of our ratio. So the common factor will be r cube. So r cube, we have r cube here, we have r cube here, we have r cube here, right? So r cube, this means it's r to the power 3 plus 2, r to the power 3 plus 1. This one is r to the power 3. So when we take out the common factor of r cube, this is what we have, right? So r cube times this, we get this. R cube times this, we get this. R cube times this, we get this. Remember, r times r, since the bases are the same, we add the exponents. That's how we get 4. R times r, the bases are the same, we add the exponents. That's how we get 5, right? So whenever you take out the common factor, check if you have taken out the common factor correctly by multiplying out. If you multiply out and you get the same thing, this means you have taken out your common factor correctly. Okay, so on this next step, remember I said you can change this from mixed fraction to improper fraction, right? So I changed this mixed fraction to improper, and I also changed this mixed fraction to improper fraction. And remember, a plus ar squared is given as this. This was our first equation. So it is given, the sum of these first three terms is given by this. And we see here we have the sum of the first three terms. So where we see this, we will substitute 31 in 1 over 2, which is given by this improper fraction, 63 over 2. This mixed fraction is given by this improper fraction, 63 over 16. Do you get it? So since we want to be left with r cubed on the left, so what we will do, we want to eliminate this. So how do we eliminate this? By multiplying both sides by the inverse of this. What is the inverse? We just swap the denominator and the numerator. So remember, whatever you do on the left, you also do on the right. This is what we have. We multiplied both sides by the inverse of this because we want to eliminate this. So the inverse of this, we swap the numerator and the denominator, 2 and 2 divided by 63. Both sides, we do the same thing. Remember, one thing that you have to note, whenever you multiply inverses together, you get 1, right? So the product of any inverses is 1. So these two are inverses, so we get 1. So that's why on the left we'll be left with r cubed. So if you use your calculator by substituting this in your calculator, you will get 1 over 3 on the right. So from 1 over 3, how do we remove this exponent 3? By introducing the dead root on both sides of the equation, right? So if you introduce the dead root, this 3 will be eliminated and you'll be left with this. So what is the cube root of 1 over 8? The cube root of 1 over 8 is 1 over 2. So we have answered our questions. The value of our common ratio is r is equals to half. So if you prefer, you can try to use these equations to solve this question. You must get r is equals to half. So you can try. If you have any problems, you can DM us. So thank you for joining in on this lesson. I hope everything was clear and understood. If there's something that is not clear, don't be afraid to comment comment. That's what I can say. So yeah, take care. Thank you very much for joining in on this lesson.